We are going to discuss about the human and colorful world. So human and colorful world is nothing but what is the human eye speciality. The eye is a very important organ in our body. So we can see each and every object in the world so by using of a human eye. So with human eye only we can see the colorful world. Okay, so in our daily life we can see that each and every person has their own eyes performance to observe the other eyes. So how it is a organs are important. The eye is also behaving like a one kind of the lens. So in our daily life we can see this kind of the activities and everything by using of a most probably all people are there using a spectacles also. So in our daily life we see that so different type of communication systems and as well as the different type of spectacles we are using by using of an eye only. Eye is the important organ. All people they know that. So the blind people, once you observe that how the blind people cannot identify any objects. So that is a very difficult task to identify. So we can easy to identify by using of a right. So what is the eye performance? What is the use of the eye performance by seeing of a other objects? For example, small kids are ready to present their objects and everything. For example, their lovable persons are coming long distance. They can easy to recognize. Some aged people they are using this kind of the area and they are using the thick spectacles also. They cannot see the distance objects. So why the different people has a different type of the eye vision is there. If any reason is there to identify the vision is a different means. Now in this topic we'll discuss the total about the eye, human eye and colorful world. So first one is a least distinct vision. Okay. So least distinct vision. What is the meaning of the least distinct vision? So how much of distance we can able to see perfectly? Okay, for example, in that area the before or after or otherwise before that we cannot see the objects clearly. The least distinct vision means least distance from the our human eye up to which area you can able to see the object perfectly. By using of this least distinct vision we can identify. Now I'm going to say that example about the different. For this activity you can see that different type of age group people are there. So for example the small kids are there. Okay, so small kids means below 10 years age people are there. Okay, so below 10 years age people they can able to see that long distance objects also. Do you know that their lovable people are coming long distance, they can able to identify. Okay, and for example adults. Okay, so adult means for example young people. We feel that is a young people, and the three category of people are there: the below 10 years people and above 10 years means we feel as a somewhat adult people, right? So young people. So then next one above 68 years. Okay, so these are the different type of categories are there. I am going to categorize that below 10 years and so about 60 years. The middle people the remaining. Okay, according to that eye performance is different, but an average in the survey they identified that different people how much of least distance value of a human eye they identified. They identified within one activity. What does that means? Below 10 years age people, the numeral they given, the survey people they given that the below 10 years people they can able to see that the distance is 7 to 8 centimeters. Okay, what is that? So it is a 7 to 8 centimeters, up to 7 to 8 centimeters to the eye, they can able to see that. Do you know that for example you can bring any book. Once you observe that this is my palm is a book, you can feel that. You just keep this is a palm is somewhere, okay, able to see that your palm perfectly, right? So then you see like this, okay, right, I am going to able to see that near, and if I keep like this then I cannot see it in my palm clearly. So because of the reason there is a least distinct value we differed. Okay, that's why what is that, up to 7 to 8 centimeters the below 10 years people can able to see that. So and I will say that why I will say Okay, so then after that, the above people, above teenagers or young people, how much of distance they can able to see that? So that is a 25 centimeters. So up to 25 centimeters from the eye, they can able to see that perfectly. That is a adult people. And what about the 60 years age people? Okay, so what is that? 1 or 2 meters. So what is that? 2 meters. Here the category changed. See that here the up to centimeters only, but here the category changed to the meters. What is that? 1 or 2 meters. Up to that distance only. You can ask any aged people. You go and show something. They can keep like this. They will keep some distance and they can able to see that. Then only. So what is that? 1 to 2 meters is above 60 years. Why we categorize this kind of the things? Means our muscles are, for example, below 10 years people, you can see that. You observe that their muscles are very flexible, because the time below 10 years people is like a chubby, okay, cheeks, and these kind of the total muscles are very flexible. So some people, they may just give a pinch of the particular people also, they can feel that is a good, means it looks very nice. And what does it means? That is the muscles are very flexible, they can sustain up to 7 to 8 centimeters at least distinctive vision values also. But the adult people are not like that. As compared to the below 10 years people, adult people are somewhat muscles are stronger. And then above 60 years people are there, their muscles are not sustained, it is not flexible. So totally 100% is not flexible, means then we can feel that their eye vision is a 1 to 2 meters or 1 or 2 meters. Right, so these are the different type of categories what we have to see the least distinctive vision. Now we discuss about the one kind of the activity. That activity can identify the how much of distance or how much of the object size. For example, I am going to discuss in detail. For example, you can bring so you go to the any cloth center and you can bring a roller. So one roller is there, for example, it's a 30 centimeter roller is there. Okay, you can bring the 30 centimeter roller, and next one is you can bring the 40 centimeter roller. So height, so 40 centimeter roller and the 50 centimeter roller, like this. So different size of rollers you can bring it. Okay, so listen, you can see that you can bring first roller and you can keep near to your eye. And you can keep in front of your eye, you can able to see that without changing of your eye. So without moving of your eyelid, so then you can able to see the two ends at a time. Is it possible? Okay, for example, you can bring that, you just keep that your eye is like this here. Okay, so you are able to see the sticks roller is at two ends. So somewhere is a long distance. Now you just better to just keep near to that. For example, so this is my palm is looks like is a roller. Once you keep it some long distance, I can able to see the two ends. Okay, without changing of my eye directions. Then slowly I can move front. Then some right, not a problem. But some distance we cannot see that, only the part of the particular object only we can see that. At a time two ends we cannot see that without changing of my direction of my eye. So what does that mean? For example, you can take that this is a small object, so remove this object and keep it bigger one, somewhat 40 centimeters you can keep in front of your eye. So right, so some part only, so then you can see that is a 50, means is a bigger one, more bigger one, you can see only one side or one only you can see that. Okay, another end you are not getting to see at a time, because of the reason our eye is having the cone shape of vision. Our eye is having the cone shape of vision. So cones and rods are there. Once you see that, our eye vision will looks like this. Okay, so our eye vision will be looks like this. The cone shape of the vision will present. If inside of the cone only we can able to see the object clearly. For example, you see that in this situation, for example, this from 30 centimeters also we cannot see the two at a time ends. So what does that mean? So practically they identified the what is the angle of the vision. The angle of vision will be there. The angle of vision is a 60 degrees degrees. Okay, so what is that? Up to 60 degree is, so we can, our eye is able to see without changing of the direction. The eye can see the two ends at a time. The more than the 60, so it is not possible to see the object two ends at a time. So they given practical, that is a angle of vision. We call as a angle of vision as a human eye. According to the age wise, it may differ, small difference will be there, but most probably there is a below 60 is a, what is that? That is a angle of vision, right? The structure of human eye. So very important in this topic, the structure of human eye is a, it behave like a lens, right? The how the refraction will take place in our eye is also, it is a visible thing. It can be identified each and every objects by using of a human eye only. Our brain recognize with a human eye only, right? So in that is the first sense organs. It is the first one sense organ in this. This is a total. This is a structure of a human eye. In the structure of human eye, I am going to say that these are the, once you see that, the main important is the retina. Okay, so in the retina, what it will be, there means it is a all are like a nerves type of arrangement will be ready to present, right? And here these are optic nerves are there. It is right to travel to the, it is right to connect it to a brain. And here, once you observe that the ciliary muscles are there, where we are going to see that this is the lens. The pupil has to present. This is our lens. Okay, that lens, above the lens, the ciliary muscles are there. And here the iris is also right to present here. And next one is a, in between the eye and the lenses and pupil and as well as the cornea. So we have one kind of the liquid will ready to present, that is called as the aqueous humor. So when we are going to cry or when we are going to do something, is a disturbance to our eye, then definitely it will give a, so water droplets is nothing but there is a, not a water, there is a aqueous humor, there is a liquid, right? And cornea is there. This is why in our physics we are going to discuss the main important thing is a pupil. Okay, main important thing is a pupil. The pupil means what is that? It is a lens type of arrangement. How it looks like, I am going to draw here. Once you see that, so this is a look like a biconvex lens. It's look like a biconvex lens. And here the ciliary muscles are there. So these ciliary muscles, what they will use means, see, for example, I want to see the nearby objects, or I want to see the small objects. So how we will see that? I can extend my eyes, yes or no? If I am going to extend my eyes, then only I can see like this. I can extend my eyes. For example, the more brightness is there. For example, you want to see the more brightness, a light. So directly you want to see means directly you will, your eyes are right to contrast. Contrast means it comes closer. So in this total is a expanding or contraction by using of a ciliary muscles only it can be useful. This kind of the muscles can adjust the zooming like a, so accommodation eye, we call as a accommodation of the eye. These ciliary muscles are right to just using as a expansion or contraction, so to the particular pupil. That is a special category of the ciliary muscles. Okay, right. So if the rays, any ray is coming from infinity, if it is right to fall on a pupil, directly the pupil is a one kind of the receiving nature. It can be right to receive the light. For example, the light is right to come and it is right to refract. What it will be saying as a, this is look like a biconvex lens. Biconvex lens is nothing but it should be so ready to enter into inside. Then when it will right to reach to the retina. Okay, so then only the brain will recognize the color and shape of the particular object. We want to see any brightness or shape of the object. The light has to enter inside of the retina and it is right to fall on a particular retina. So inside of the pupil and it will make as the image on retina. This place is a image position. In this position only the image has to capture. Listen. One, this is a lens. You feel that this is a lens and this is a image position. Then what we feel that this is a meeting point. I said it is a meeting point. Meeting point. What I said, that is called as a after refraction. The rays will meet. That point is a focal point, and that length is a focal length. Yes or no? In our lens topic, we already know that is the refraction of light. What does it mean? This is a focal length. Okay, so here this image position is a fixed every time. Image position is not changing. Image position is 100%. What does it mean? Indeed, on retina only. That's why image position is a fixed one. What is the value? What is the distance between the lens to particular retina? Means that value is a f is equals to focal length is also f is also is there 2.5 centimeters. What it will be? So actually the least distinct division of a human eye is a, what is that? Object distance. Least distinct division of a human eye is a 25 centimeters. So here that is a VRF. So both are image position or image distance or focal length is a 2.5 centimeters. By using of these values only we can find out the maximum and minimum focal lengths of the human eye. Okay, maximum and minimum focal lengths are there. In that maximum and minimum focal lengths we need to calculate the value. So f is equals to, I want to calculate the maximum focal length. Okay, so I want to calculate the maximum focal length, what it will be by using of a human eye. So here u value, object distance, we don't know what is the value. That's why infinity or minus infinity or plus infinity, whatever it may be, there is an infinity, means where the object position is we don't know. That's why so in front of I the u value is a infinity, and as well as what I said that v value, I already know that value is a fixed one. It should be the 2.5 centimeters. Here the sign convention it will give as a positive only. In the lens topic, in a biconvex lens especially, in that this is a u value is a negative and v value should be positive. And now I am going to use a formula 1 by f is equals to 1 by v minus 1 by u. So here this is a lens formula what we are using. In this formula I am going to substitute that 1 by f is equals to, here what it will be, 1 by v means what is that? 2.5 centimeters minus of 1 by u means there is a minus infinity. So something by infinity is nothing but 0. 1 by f is equals to 1 by 2.5 and f is equals to 2.5 centimeters. So this is a value of the what I said just now. The f value is if image distance. That's why the maximum focal length. This is called as a maximum focal length. Okay, f maximum is equals to 2.5 centimeters. Now we need to calculate the minimum focal length. We need to calculate by using of a value. What does that mean? Here the minimum value I am going to use that there is a u value, object distance is a minus 25 centimeters. See here there is a, what is the 25 centimeters? The least distinct vision of a human eye. Okay, least distinct vision of a human eye. So that's why minus 25 centimeters I am using, and here there is a v value is a 2.5 centimeters. You already know that what is the value? It is a fixed position. The image distance should be fixed. Now I want to calculate the f value, f minimum. Now in this situation, what is the formula? Lens formula 1 by f is equals to 1 by v minus 1 by u. Then I am going to substitute all the values. 1 by f is equals to 1 by v means what is that? It should be, so 1 by v means 2.5 minus of 1 by u means minus 25. So here I am going to change as a 1 by f is equals to 1 by v means 2.5. So plus minus into minus plus. So 1 by, so 25. Now the 1 by 2.5 I want to change it as a value 1 by f is equals to, then I want to write the 10 by 25, correct? So how it will come to means just I am going to say that 1 by 25 by 10 I am going to write. So plus 1 by 25. In this situation the 10 is a reciprocal. The reciprocal of the, so 1 by 25 divided by 10 means it will go up. So then 1 by f is equals to 10 divided by 25 plus 1 by 25. So in this situation here the bases are equal. Okay, that, so this down values are equal. 1 by f is equals to, what is that? 10 plus 1 by 25. Now I am going to write here. So 1 by f is equals to what it will be? So 11. So 11 by 25. Then both side I am going to take as a reciprocal value. F is equals to, so 25 by 11. So here the 25 by 11 means in 11 table what it will be? So 11 ones are and 11 twos are. Okay, 22. Okay. So here the more 3 values are there. So 3 means point. Okay. So again point means 25 again. So what is the 25? Again 11 twos are. So 22 again 3 like this. Okay. So approximately 2.27 centimeters. F is equals to what is the value? 2.27 centimeters of the is the minimum value. That is the F minimum value is a 2.27 centimeters. So what is myopia? Myopia is nothing but it is a one of the defect. So what kind of, actually in our daily life we have the different kind of people have the, so different type of eye visions are there. So what kind of the eye visions means? There is the first one is a myopia and second one is a hypermetropia and third one is a presbyopia. These are the different type of the, so defects, eye defects are there. So that is very important. This is the first one is a myopia. So myopia is nothing but what is a myopia in that? So simple logic. Some people they cannot see the long distance objects. They can able to see the nearby objects only. They cannot see the long distance objects. So that's why what we said that is called as a myopia. The people are not seeing the long distance objects. They cannot see the long distance objects is said to be, it is called as a myopia. And this is another name is also there, that is a nearsightedness. What is that? Nearsightedness. So in that nearsightedness, then now I am going to say that the diagram, the ray diagram looks like this. For example, this is the eye vision, this is a lens inside of the eye. Okay. Then from long distance the rays are coming. From long distance the rays are coming and are ready to refract from our eye. So what I said that this is a retina. Okay. So we already know that this is a retina. So the retina has to receive the signals or light, then it will transfer to the brain. That is another issue, right? Now here what I am going to say that actually, so after refraction all rays will meet on retina, but it is not possible in front of the retina the all rays are meeting. So that's why it is a one of the defect at the time. So we will see the blur type of image. We cannot see the proper image. So then this is called as a myopia defect. Okay, how to overcome this defect? So simple logic. So what I am going to say that it should be just meeting on in front of the retina. But I am going to say that if these rays will meet on a retina, then it will be perfect. That's why I am going to use so what is that? Biconcave lens, because it is a divergent. Okay, so divergent I am using that biconcave lens is ready to just diverge the lens. Now here only it will diverge the lens. See that? So it will diverge and ready to meet on a retina. Once you see that, if I am going to say that all rays will meet it at the position of a retina only. So that's why it should be called as a, here all rays are meeting on retina. It should be okay. So if I am going to consider the three rays, the three rays are meeting on a retina. Now it is a diverging. So where it is, the light just comes closer, then it will diverge and it will mix to form a image on a retina. This is a myopia defect. Myopia defect means, again I am going to explain what is that. The people are not seeing the long distance objects. They cannot see the long distance object. They can see the nearby objects. That people having the myopia defect. And another name is a nearsightedness. So nearsightedness is right to form an image in front of the retina. If you overcome this problem, if you resolve this problem, then I can use in front of the eye, I can use a biconcave lens, then it should be ready to fall an image on a retina. This is called as a myopia defect. By using of a biconcave lens is useful to resolve this problem. Now hypermetropia is there. Hypermetropia is nothing but what is that? So in myopia, what we discussed that the long distance object they cannot see. The people, those who have the myopia defect, that people they cannot see the long distance objects. But here, what it will be there that hypermetropia means, in that hypermetropia, so that people they can able to see the long distance objects, but they cannot see the nearby objects. They cannot see the nearby objects. That is another name is also there, that is called as a far-sightedness. What is that? Those people are not seeing the nearby objects. They can able to see the long distance objects, but they cannot see the nearby objects. That people having the hypermetropia defect. And as well as another name is also there, that is called as a, what is that? It is a far-sightedness. Then how the diagram has to look like this? This is a human eye, and here these are the rays are ready to affect. So this is coming from infinity, right? After refraction from our human eye, and actually the normal eye is right to affect the meeting point of the refracting rays on retina. But it is moving away from the retina, and the back of the retina they are meeting is a focal point we right to consider. So meeting here, then what we conclude from this kind of the problem means this is called as a hypermetropia. It's a far-sightedness. So that's why it is just moving back of the retina means. So in myopia they are right to meet on in front of the retina. In a hypermetropia the rays are right to meet on a back of the retina. So these are the problems. Now how to overcome this kind of the problem? Actually the moving back of the retina, then I can overcome this kind of the problem by using of a biconvex lens. Okay, so if I use in front of our human eye is a biconvex lens, it is a converging lens. So converging lens means it won't meet in the back of the retina. So directly it should be meet on a, so what is that? On retina. It will adjust the, so now it should be meet on a retina. Then we feel that what is that? Now it became as a proper shape of the object will appear. So now we can overcome the problem by using of a biconvex lens. Hypermetropia is overcome with a lens of the biconvex, and myopia will be having the biconcave lens, it will overcome. So these are the two, and another one is also there, that is a presbyopia. So here the dispersion topic, and actually in that the dispersion and scattering is a dispersion is nothing but, in our daily life we can see that dispersing. For example, I want to disperse the books, I want to disperse the notes. So what does it mean by dispersion? Means it is right to divide, okay, in a single ray of light. According to the physics, what we are going to say that if we consider a light, if one color of a light is right to divide into several colors of light is called as a dispersion of light. Okay, so now which is a good dispersion of light? Means there is a which is right to divide the single ray of light to the multiple rays of lights. See, nothing but it should be the one instrument is there, that piece is a, what is that? Prism. The prism is the best example to divide the single ray of light. So once you see that, I am going to draw here. This is a prism is there. Now the prism is a transparent and like a triangular shape. Okay. So triangular glass shape, or just three sides are okay. So these are the different sides are right to present. It's a triangular shape, and here this is a prism. When any ray of light is right to fall on a particular prism, what does that means? This is called as a incident ray. We already know that. According to the ray is called as a incident ray. Okay, so incident ray is right to fall on a particular one side of the prism. Then after that, what it will be? The rays has to enter inside of the prism. It is right to travel, and it should be refract, the bending of a light. Okay, so bending of a light. Now you see that the bending of a light, and it will try to travel from one place to another place. When it comes to the another side of the prism, again it should be ready to come out of the prism. That's why you see here also it is ready to bend, means refraction will take place. Again it will come out of the prism. Once you observe that, initially the rays will looks like this kind of direction. Okay, and finally what is the direction of the ray? It should be like this. Once you observe that, how much of the bending has to present? So this much of bending has to present in our prism. This is called as a, what does it means? Angle of vision. Angle of vision. Okay, so what does it means? So this is a angle of deviation. Okay, so deviation. So angle of deviation, here this is called as the angle of deviation here. So what does that mean? This is called as the incident ray, and here also the one ray has to come. So that is outside of the prism, means this is called as a emerging ray. Emerging ray or emergent ray. So this is called as a emergent ray. This is the angle of incidence. You already know that there is a I. So then next one, it is also the angle of deviation will be there. D sometimes we will show with a symbol D. Okay, small d is the angle of deviation. Is the emerging ray is also having the angle. It should be refraction. So we already know that there is a refraction will take place. These are the different kind of the things are there. Incident ray, angle of deviation, and emerging ray. Okay. The derivation formula for the refractive index of a prism. In our prism, so what is the refractive index value? You just find out by using of a derivation formula. By formula, for example, I want to do that. I want to bring a one prism. The prism is a points P, Q, R. The 3 points are there in the prism. In this situation, once you see that, if I am going to consider one incident ray is coming from infinity, is ready to fall on a particular PQ surface of the prism, then it is the end position of a prism. Then it is right to refract. It will right to enter inside of a prism, and it will right to travel from the M to N. Okay, so here there is again it is the end position. Again it is right to refract. Again it is a refraction will takes place. The emerging ray is coming out of the prism. So this is the mechanism. Inside of the mechanism, if I am going to draw a angles, once you see that is actually, so without prism the direction of the incident ray is a, so this dotted line will indicate, and as well as what is that, this kind of the emerging ray looks like to appear as a, this dotted line will explain that. Here once you see that this is the angle of a prism, A is going to indicating as a angle of prism. Now the way the two dotted lines are right to meet, that point is a O, and here the angle of deviation, or so how much of maximum angle should be deviate the light, that is called as a, what is it, angle of deviation is a D, right? Okay, so these are the angle values, and this is the incident ray angle, or incident angle is a I1 from the first one, and after refraction the ray is right to enter into a prism, that is a R1 is a refraction of a angle. So then it comes to the same position of a N position. These rays right to saying as a R2 incident angle now. Okay, so then here it will be that after refraction it will be saying as a I2. Okay, so these are the angles and everything. Once you observe that it is a OMN, it look like a triangle, right? Yes or no? So now the triangle formula, triangle OMN. Okay, so from the triangle OMN, so in this triangle what does that mean? Sum of the, okay, so interior angles is equals to sum of the exterior angles. Sum of the interior angles means what it will be? The sum of the interior angles. For example, exterior angles I am going to write. So here the exterior angle of this O, that's why the D is equals to what it will be. Interior angles means we don't know what is the value. That's why what I am going to say that is a, you see that is a co-linear or okay, angles are there. Okay, that's why it's I1 minus R1. Okay, so I1 minus R1 is the one angle I am going to consider. So we don't know. That's why this is I1 and it is a minus R1 and plus another angle will be there, means this is a I2 minus R2. I2 minus R2. So this is the one equation. Now I am going to change as a minus values and plus values will separate it. Okay. I1 plus I2. I1 plus I2 minus of R1 plus R2. So this is the first equation I am going to consider. Right. So after completion of this one, now we'll go for the one more angle is there. That is a triangle is there. There is a PMN. Okay. Here the triangle PMN. So triangle PMN. So in this triangle, what I am going to say that. So here what is the interior angle is A. And here once you observe that is the exterior angle is also ready to present here. Okay. Now here I am going to say that sum of the, here the formula has to change. The sum of the interior angles is equals to 180 degrees. We already know that. So that is a mathematically is a triangular formula has to present sum of the interior angles is equals to 180 degrees. That's why what does that means A. So A is a one angle plus once you observe that. So we don't know the total value. That's why what is that actually the each and every angle should be 90 degrees. In the 90 degrees the okay, I am going to just subtract the R1 value. That's why this is the value of the particular area. So 90 minus R1 is a one angle. Okay, so plus 90 minus R2 is a one more angle of this one. So the total is equals to 180 degrees or 180, right? Now I am going to separate it. That is A plus, so 90 plus 90 is a 180. 180 minus of R1 plus R2 is equals to 180. So that 180 is gets cancelled. This minus of R1 plus R2 will goes to outside of A equal. It should be A is equals to R1 plus R2. This is the second equation. Now I am going to substitute the value in a first equation. Okay, the first equation from equation 1. Okay, so what it will be equation, again I am going to write the D is equals to, what is that, I1 plus I2 minus of R1 plus R2. Okay, in this what is that, R1 plus R2 is equals to A. That's why what is that, D is equals to I1 plus I2 minus A. So minus A will go outside of A equal, it should be become as a plus. D plus A is equals to I1 plus I2. This is the third equation I want. Okay, so in these equations I am going to just see that. Now I will go for the Snell's law. These are the values. Okay, in this equation now I will go for the Snell's law. We already know that Snell law is there. The Snell's law. Okay, so what is the Snell's law? N1 sin I1 is equals to N2 sin, okay, R. So otherwise N1 sin I is equals to N2 sin R. So this is a Snell's law we have. So by using of a Snell's law, first of all I want to know that what it will be, there is a N1, N2. So this is a N1, the refractive index 1 and this is a refractive index 2. So we don't know what is the value of a refractive index of a prism, but we know that refractive index of a air. So what is that? Every time the air refractive index value should be 1. So that's why in this situation is a M position at M. So M position, what it will be at M? You can write that is a at M. At M position. Now what is the value of a N1? N1 is equals to 1. Okay, but N2 we don't know. What does that mean? That is N2 is equals to N only. I need to take as a N. So what about the I1 is the I is equals to, what is the value? I1. Okay, incident angle is a I1. So then what about the R value? Is a R1. Okay, now I am going to substitute these all values in the Snell's law. So N1 means 1. So 1 into sin I1 means I1 is equals to N2 means N. Okay, sine r means what is that? Sine r1. Okay, so then sine I1 is equals to n sine r1. Okay, so this is the one formula we have, and now we'll go for the at position n. Now the position n it has to change. What is the value at n? Now at n, now once you see that here we can change the values. So what kind of the values it will change means, once you observe that what is the incident angle here, there is a R2. So that's why first of all what about the n1 value? N1 is equals to what is the, now here it is a n1. So it is not a n2 because the air will start, light will start in this position now. So that's why n1 is equals to n. And n2 is equals to 1 because it will enter the second refractive index value is a 1 because it is entered into a air. So that is a n2 is equals to 1. And what about the I1 value here? That I is equals to R2. Correct or not? So here there is a starting point is a angle is a R2. So that's why refraction will take place. R is equals to what it will be? I2. Okay. So then now I will substitute the formula in that Snell's law. N1 is equals to n into sine I means that is a R2. Sine R2 is equals to what it will be? N2 sine R. N2 sine R is nothing but what is the N2? 1. 1 into sine I1. Now I am going to write n into sine R2 is equals to sine I. So this is the fourth equation. Okay, now these are four equations we got it. Then after completion of this one, now what I am going to say that, so this is called as a, okay, now we need to consider as a, here in that particular area, if I am going to consider the values, I1 is equals to I2. Okay, so this is a condition we are right to consider. Then let I1 is equals to I2. Here the I1 is equals to I2 means once you see that what kind of the changes will appear in that. Okay, so we already know that the values are there, that should be I1 plus I2 means I1 plus I2 is nothing but where the values will be there. Now here A plus D is equals to I1 plus I2 is there. Okay, so in this situation what does that means? D is a angle of deviation. Now I will consider, I will keep it as a capital D. So what does that means? A plus D is equals to what it will be? I1 plus I2 means that is a 2I1. For example, if I consider that both are I1 means that is a 2I1 is a fifth equation now. Okay, so then if I am going to take as a R1 is equals to R2, let R1 is equals to R2. In this equation what it will be that A is equals to R1 plus R2 is there. That's why what is that? A is equals to 2R1 or otherwise R1 is equals to A by 2. The two values will go to the bottom. Okay, so otherwise your wish, you can take as a, if I am going to take as a values means in this equation once you see that R1 and I1, so both values we got. I value also I am going to write here, that is A plus D by 2 is equals to I1. Actually this is the fifth equation. Okay, so this is the fifth equation what we have. Now you substitute all the values in that Snell's law what we have. This is a, okay, is the fourth equation is this is, now this is the fifth equation actually, and this is the sixth equation, right? Okay, now I am going to substitute the values what we have, the A plus D by 2, I1 value and R1 value is there. Now I will substitute all the values in the fourth equation. From equation 4, then you see that sine I1 means what? I1 is nothing but it is A plus D by 2 is equals to, what is that? N sine R1. N sine R1 means what? A by 2. That is A by 2. So if I am going to write that N is equals to sine A plus D by 2 by sine A by 2 is a formula for the refractive index of a prism. Okay, so this is a n is equals to sine A plus D by 2 by sine A by 2 is a refractive index of a prism value. So a prism with an angle A is equals to 60 degrees produces an angle of minimum deviation of a 30 degrees. Find the refractive index of material of the prism. Now here the one question they given, there is a value is given as a 60 degrees, and here the value maximum deviation is a D is equals to 30 degrees they given. So you can calculate the refractive index of a prism, n value we can calculate it. So by using of a formula, what we have the formula n is equals to sine A plus D by 2 by sine A by 2. This is the formula we can need to use. Then here once you observe that n is equals to, I need to substitute the all values in the above equation. Sine A plus D means what is the A is a 60 and plus D means 30 by 2 divided by sine A by 2 means sine. So A means what is that? 60 by 2. So here this is a formula. Now I am going to say that n is equals to sine 60 plus 30 means 90 by 2, and here the sine, so 60 by 2 means that is a 30. So here there is a 30. Now sine 90 by 2 means what is that? It is a sine 90 by 2 means 45 degrees by sine 30 degrees. Now here once you observe that sine 35 and sine 45, the sine 45 degrees is equals to, so 1 by root 2, that is a value, right? And sine 30 degrees is equals to 1 by 2. These are the trigonometric formulas in your mathematics, it will be present. So then I am going to substitute the sine 45 value 1 by root 2 divided by sine 30 means it is a 1 by 2. If I am going to write in a proper way, 1 by root 2 into 2 by 1. Okay, so now it should be is a 2 by root 2. Now there is a root 2 value is down, means I am going to write that root 2 by root 2. Once you see that, there is a, what is the meaning of that? 2 root 2 is the above value. Root 2 into root 2 means root 2 square. Root 2 square means I will write root 2 square. Root 2 square means square and root will get cancelled. So now I will write here. So here there is a 2 root 2 divided by, so it is a 2 value will present. That is a 2 is gets cancelled, root 2 has to present. So this is the, what is the value? N value. Refractive index value is a root 2. Okay, so we can do one activity to identify the maximum deviation values or different type of colors in a water fountain in our area, in your home or in your room. We can do that. So what kind of the activity will be there? Means for example, in your dark room, you just consider as a, you can take as a one dark room. Inside of the dark room, you can arrange one source of light, the white color of light, you can observe that. And then you better to stand in front of the any wall, and then the back of you ask your friend to just use the water looks like a fountain. Yes, so the looks like a fountain means the water is right to sprinkling, this is coming out of the pipe or something. So then you ask to just switch on the light is the back side of the particular pipe or particular water fountain. You ask to just switch on the light. Is a source of light, it should be is a straight light. Otherwise you can use that as a wooden plank to make a hole and switch on. So then what automatically what will happen? The single ray of light is ready to fall on your water droplets, and different type of colors will appear on a screen. So what we conclude from this? Yes, the single ray of light is a white color ray of light is right to divide into several colors of light. So this is a one kind of the experiment to find out the different type of colors of light in our daily life. What it will be there means you consider as a one metal tray. So metal tray is right to present, that is a, for example, this is a metal tray, and in that metal tray you arrange 145 degrees of a mirror. Okay, so you arrange 145 degrees of a mirror, and then you pour that half of the mirror has to fill with a water. This looks like this. Okay, in this situation I am going to observe that 45 degrees and this is a mirror has to present. How many mediums are right to present? Either the water is water is behaving like a prism because of the reason. So if any ray, for example, you ask to enter some kind of the rays inside of the water, what will happen? The rays are ready to fall on a particular water, it should be ready to reflect it again. So in this area what we are going to, the light has to chosen is the least angle of deviation. Means, for example, in our lower class we already know that if any ray of light is ready to fall on a particular area, the angle of incidence is equals to angle of reflection. Means how much of angle it is ready to present, the same angle it should be reflect. So here also that means the rays are ready to fall on a mirror by using of a water. Then after that it will come to the some least value, least path it will select to refract, or it will try to reflect. So this is the nature of the light. Now we can go for the dispersion of a light. How the dispersion of light has to present? The dispersion of light is nothing but, for example, the white color light is there. So do you know that white color light? So this is a white color light is there. The white color light consisting of 7 colors in it. Okay, the single ray of light is a white color light, but it is not a single ray of light. The white color contains the 7 colors in it. The what kind of the colors will be there? Means VIBGR. Okay, so VIBGR. So the VIBGR is nothing but the each and every letter indicate the one kind of the color it will be. So this is called as a violet and indigo. I means indigo, the B means blue, and G means green, and Y means yellow, and O means orange, and R means red. So what is that? Violet, indigo, blue, green, yellow, orange, red. So these are the 7 colors are present in a particular white color. So this is also called as a rainbow colors also. Okay, the basic colors are rainbow colors has to present in a VIBGR. Okay, so these kind of the colors will depend on a, for example, if you go for the light. So how can we say that is a 7 colors has to present? Some colors only ready to appear, some colors are not appearing. So because of the reason that depending on the refraction, so depending on the dispersion will be on a particular wavelength, and so what does it means? Angle of deviation. So these are the angle of deviation and wavelength. These wavelengths are ready to present in our. So here if I consider as the light is also look like a wave. Once you see that this is a wave, what I want to say that wave, the sound waves, how the sound waves are ready to present, same as that is a light is also considering as a wave. I hear that this is a up value and down value, means this is a up and downs are there. So here we can call as a, this is called as a, from this position to this position is a, one is a positive half cycle and the remaining is a negative half cycle. Then it is called as a wavelength. Wavelength will show with the symbol lambda. The Y is a reverse, that should be called as a wavelength lambda. And one more thing, there is a frequency is also right to present, or F or N. Sometimes they may show with a F. The frequency of the wave. The frequency wave is right to enter is nothing but number of wave. The intensity of the wave is said to be, it is called as a frequency, right? For example, how much of the wave has right to present. So that is by using of a frequency only. Once you observe that in our VIBGR color, the each and every color have their own wavelength and as well as own frequency. Okay, so own wavelength and frequency has to present in our area. Once you see that if the prism has to present in this prism, if any single ray, what is the white color ray is ready to appear. Once you see that in this area, now what I said that it should be ready to refract. So this is a violet color to red color, VIBGYOR. Vijaya. These kind of the 7 colors are right to present. Here, once you observe that in our situation, the R is nothing but less deviation. Means the red color is a less deviation, more wavelength. Here, once you just consider and keep in your minds, and here that less deviation, more wavelength. More deviation, less wavelength. Okay, and here that the wavelength is having more. So here the wavelength is more means it need to travel long distances. Okay, but intensity of the red color is not more. There is a less intensity. But here the Vijaya color, the V is a violet color now. Is a more deviation will be there and more intensity has to present. Okay, it is not to travel more distances, but it has more intensity, more power. Okay, so once you observe that, why we need to use the signals colors are red color. There is a danger symbol is also using as a red color. If any reason is there means yes we have reason. What kind of the reason it will be there means the red has to travel long distances because their wavelength values are more. Okay. So, but intensity, once you see that if you comes to the red color, orange, yellow, and here once you observe that orange color is nearby the red color means it is going to mix. In a Vijaya also we cannot see that all colors at a time with our eyes because of the reason some colors are right to just mixing with other colors. Okay, so accompanied with the other colors. Okay, so not a problem. You can see that there is a yellow color is using in a signals. And as well as there is a green color. Okay, up to green color we are using the signal stop and so think and go. Right, so these are the colors we are using. If you know that if a more kind of wavelength values are there means there is a less intensity and as well as there is a frequency values are less frequency, more wavelength less frequency. The formula is also there. There is a V is equals to nu into lambda. Here the nu means the frequency or otherwise F into lambda. So do you know that is F? So F into lambda. What is the V means? What is the speed of the light? There is a V is equals to speed of the light or sometimes we can call as a C. So speed of the light in a vacuum. This value is also the 3 into 10 to the power of 8 meters per second. The speed of a light in a vacuum is a 3 into 10 to the power of 8 meters per second. Okay, we don't need to go for that. There is a C is equals to F into lambda or otherwise this is a constant means there is a F or lambda is proportional to 1 by F. So what is the meaning of this one? So wavelength is inversely proportional to the frequency. If more wavelength, less frequency. More frequency, less wavelength. So that's why it is a reciprocal value means inversely proportional. Here also the more wavelength has to present less frequency. Here the more frequency will be ready to present less wavelength. According to that wavelength and frequency wise their positions of a light has to present. Now some interesting things are there in our daily life. What kind of the things are there means for example you know the look sky. The sky is looks like a blue color. So why it is a sky is a blue color? If any reason is there, means definitely we have this reason is there. In that scattering of light we can discuss. And but one thing I am going to ask question raising in our minds. What does that means? Why the raindrops are right to give a rainbow? After raining only that rainbow has to present. Yes or no? In our rainbows, what it will be ready to present that after raining, in some situations only, some areas only will get the rainbow. Is the 7 colors will ready to appear. The Vijaya colors are ready to appear. But every time after raining, it won't appear. Why? It is a raining after raining, it won't appear means because of the reason. Here this is a water droplets. Okay. So this is a water droplets. When the sun rays are ready to fall on a particular water droplets, it is ready to enter inside of the drop. Then it will comes to the another end of the drop and ready to reflect again. So what it will be there means this is a one kind of the light is ready to. It is a prism. It behave like a prism. So in this prism, now once you observe that is a single ray of light, that is sun rays are right to falling. Because of the reason in our environment, after raining, the small water droplets are ready to present, means there is a water vapor. Okay, the water is ready to present, the humidity is also we can call. So here that there is a rays if ready to enter that water droplets, instead of the water droplets it looks like a prism and ready to fall and ready to comes to the human eye. Our eye has to appear here. So in this situation, now once you observe that, what is the angle to make a VGR colors? The 7 colors has to present, means by using of a 40 to 42 degrees of a angle. Okay, so 40 degrees to 42 degrees of an angle if the sun rays and as well as our human eye has to present. So that is a thing we will get the, for example, 42. So 42 degrees of an angle only will get the rainbow colors. Otherwise we won't get the rainbow colors, because of the reason our eye is also accepting that kind of the, you already know that our eye is accepting that cone shape of colors, means cone shape of the colors has to present. Okay, so these are the reason we will get the, there is a different type of rainbows are right to present, and some areas and sometimes only we will get the, okay, write the colors, right? So if we are going to comes to the, for example, it is a cones and rods we can call. So what is a cones and rods means, for example, water droplets are there, this is a cone value. Okay, cone shape if I am going to write. So this is a cone shape now. So here that first it will form as a ring, one ring. Okay, in our 7 color, there is the first one is a red color, right? Yes or no? The red color ring has to present. After completion of this one, next color is a VGR, means orange. So next color is a, what is that next one? So VGR means yellow. Again next one like this, VGR colors, all colors are okay. So G is green. Okay, so next, so blue like this. So next one is a VGR indigo. Next one is a violet. See, what is your observation in that particular ring? Each and every circle has a one color. There is a red color, orange, yellow, green, blue, indigo, violet, right? So VGR colors are there. In these VGR colors, first of all, if I am going to see that is in a 40 to 42 degrees of angle, then we can see that each and every color in a separate manner. If it is not that, each and every color is a vanish. Vanish is nothing but mixing with other colors, right? So then the red color is mixing with the orange, and orange color will mixing with the yellow, and like this. It will try to mix and it will make it as a single color. After that, it is not 40 to 42 degrees of angle. Then it will, all colors will vanish and make it as a single color, that is called as a white color. So that is the reason we can use that. There is a vanishing of all colors in a single color is made as a white color. Okay, for example, did you know that some areas, okay, so not only some areas, some people, once you observe that the morning sun rises and sunset, okay, the sun rising and sunset both are having the red color, yes or no? Sometimes evening time also we will see that the sky is a yellow color, yellowish. So why it is having this kind of the reason means, we have one reason is there here. What does it means? The red color, what I said, that is a more wavelength. So when we are going to start, the sun rays are right to start, the first rays are right to travel the red color light, means because of the reason it is right to travel the long distances. The first initially, for example, these are the color has to present, this is our earth. Okay, in that first is a color is a, what is a big ring is a red color. The red color has to travel more distances and it will try to appear. That's why when we are ready to start the morning session, the sun rising, it will appear as a red color. Then sunset is also red color because of the reason. So lastly, the highest color is a red color to appear. So that is the reason, right? the scattering of light. Scattering of light is a very easy and very observed in our daily life. What kind of the scattering of light has to present? So simple logic, I am going to say that the rebouncing of a light is said to be the scattering of light. The rebouncing of a light is nothing but, for example, if you observe that in our surface, for example, this is the surface area is there, and here if you observe to any rays of light is right to fall on a surface area. For example, that is the sun rays are there. So here the sun rays are right to fall on this area. Then what will happen? Again, in this particular area, what kind of the particles are right to present, or otherwise electrons? According to the chemistry wise, what we know that the electrons are right to release from the particular surface area. This kind of the rebouncing, the rays are right to fall on a particular area. There is a bouncing of a particles from the surface area. Rebouncing of a particles is said to be called as a scattering of light. And here there is a rebouncing of a light we can observe by using of a millicon experiment or gold leaf experiment. In a chemistry purpose, we have that a gold leaf experiment is there, where the gamma rays are right to fall on a gold leaf. That gold leaf right to export or going to release the electrons from a particular surface of the gold. So that is a simple logic. You can go for the best example what we know in our daily life. You go for the welding shop, you know, the welding shop people are going to do welding with a one kind of the special instrument, right? Yes or no? So what kind of this special instrument, like a one white color rod has to ready to touch to the iron particles, then the particles are ready to come outside, the brightness will ready to appear. What we means that, so if I am going to take as an example, is a scattering of light is also I am going to take as an example with a welding. So not the 100%, but it looks like a, so welding is the best example for the rebouncing of a particle or re-emission of a light is right to said to be called as a scattering of light. Okay, so in our daily life, what I am going to think about, this sky is a blue color. Why the sky is a blue color? If any reason is there, so every time the sky is a blue color? No, the sometimes only morning session only, especially the sky is a blue color. And then if comes to the noon time, means is the afternoon time, if I consider to the see that particular sky is a white color, and evening time again it comes to the blue color. What is the reason in the sky is a blue color? Means simple. In our sky, in our environment, what is that? Nitrogen and oxygen, N2 and O2 molecules are there. Okay, what I said that depending on the size of the molecules will depend, and it will decide the frequency and wavelength of a light. Yes or no? What I said that in a previous example or previous discussion, what I said that there is a wavelength and frequency, both are reciprocal or both are inversely proportional. Their frequency and wavelength, their frequency especially can decide the size of the particles, will decide the frequency of a light, and what kind of the frequency means that kind of the light has to present. For example, if I will consider the N2 and O2, here in our particles, in our water or any environment, for example, the small particles are right to present. In the small particles means if any ray of light is right to present, then it should be making as a, this size of the molecule will decide how much of colors of light has to refract. So then this white color light has to refract and it will get a blue color light. So this N2 and O2 molecules only will responsible give a particular blue color light. And in our daily life, how to make it as this kind of the practical making of a scattering of light is in our daily life or in our laboratory purpose. Is it possible to make it? Means definitely, so we can make it, right? And do you know that hypo solution? In that hypo solution, I will explain that. You just see. So that is a N2 and O2 is the best example for the giving of a blue color light. Okay. Now here, if I am going to take as a, if I consider the one beaker, inside of the beaker I want to take as a, what it will be? That is a sulfuric acid H2SO4. Okay. So then as well as the hypo solution. Hypo solution is nothing but there is a sodium thisulfate. And sodium thisulfate means I am going to see here sulfuric acid and sodium thisulfate is there, means here the initially there is this sodium, okay, now all particles are right to appear inside of the particular chemical. So means if I just observe that the size of the particles are right to appear, the sulfur particles are right to appear in a less quantity. The small quantity means if I just use the light, the sun rays are right to fall on a particular this beaker. Is a transparent beaker, it is right to fall on it. Otherwise is a white color light you can consider. Then the small kind of the particles of the sulfur particles can give the blue color light. It should be look like all particles are look like a blue color. But after some time, if I give as after 5 minutes or 10 minutes or after 1 hour or 2 hours, then after some time what it will happen means then these particles, the sulfur particles are going to become as a bigger one. Okay, the chemical reactions will take place and then these particles are make it as a bigger one. Now this frequency of a particle, the size of the molecule or size of the particle is different, then the frequency of the light is also different. That's why so all white color light is right to refract and it will get the white color light only. So then first initially if the particles are small size, then it given as a blue color. Then after some time the particles are sizing increasing. Then after increasing of the size, slowly it will change the color and it will give a white color, not a blue color, right? So this is a practical example why the environment has to give a different type of colors in our nature, right?